Hey there, I hope you are doing good. Welcome to another video. Today we are going to solve machine coding question which was asked in Postman's SDE2 front-end interview. My friend was recently looking for a switch and he was actively interviewing. While interviewing, one good thing he did is he noted out all the questions that were asked to him in different interviews. As you can see over here in the Postman, he was asked 3 questions. There were 2 system design, Google Docs and design lead code, and 1 machine coding question. We are going to solve the machine coding question today in this video. The system design questions are available on my course alpha.learnersbucket.com. If you are preparing for interviews and looking for resources to master front-end system design, then you can enroll into my course and get lifetime access to it and start preparing. I have around 17 system design questions which could help you to design different or cover all the aspects of the web development. Coming back to the machine coding question, as you can see, the problem statement says that we have to create a folder structure which is something similar to what we see on the Google Drive. We have the breadcrumbs on the top and then we have the folders. The folders can have one or more items. It can be nested. There are 2 types, folder and file. A folder can have more folders or files. Files cannot have anything. So if you click on any of the folders and if they have children's, then that should be visible. Similar to how we do it on the Google Drive. Your task is to while creating or while solving this problem, they had set certain criteria based on which they will be evaluating your performance. The first thing was how suitable you define the data model, how you render the content, how do you maintain the breadcrumb trail, the one which we are seeing on the top, and then support unlimited nesting. From all these 4 items, the most primary thing I can see from here is maintaining then unlimited nesting and then having the breadcrumb trail. Now let's come back to the portal and let's start coding this. The best thing that you can do while solving any machine coding question is first read the problem statement clearly and then based on that you can start tackling. So here if I see defining the suitable data model is the primary thing that I want to do, and I want to have a normalized state because your state defines how scalable your application is going to be. If our state is well defined and it is normalized and easy to use, then we can support unlimited nesting with this. Now this comes with the practice, but let's explore some examples of state management or normalizing the state over here. From the basic structure or from the basic design, we can see that if we have to create a state, what we'll do is we'll have the structure and then you can have the nested objects. For example, you can have the id root, then name root, its type, whether it is a folder or a file, and then the children. This is the basic idea that we have while designing any of the structure based on the design that we see over here. So here you, let's say you create folder 1 and then here you name it as folder 1 and the type is folder, and then similarly I get this and I have another child and I name this as folder 2. So we have a parent and then we have a 2 folders over here inside that as a children. Now this structure will definitely work, but the problem with this is every time you have to find something, you have to go deep in the tree. This becomes an n-array tree where a leaf can a branch can have any number of leaves. So here the children can be any amount, so we cannot keep the count. That's why we are saying n-array leaf. So this structure works, but the operations that you do on this structure will be expensive. For example, if you have to find something, you have to go in each branch and look for each leaf and then see if it is available or not. So we have to perform a DFS, a depth first search, where we go and check depending upon what you use, DFS or BFS. But the ideal will be DFS, where you go into depth of each branch and see if there is a um, um, whatever we are looking for is available or not. If it is not available, then we look for in the another branch and so on. Similarly, if you have to add something, if you have to remove something, you have to first go to its trace, you have to find it and then do the mutation operation. So everything becomes expensive in this. Another type, or what we can do over here, is we can normalize this by having a flat hierarchy and we link through a primary key. So what we'll do over here is we'll have this structure. We'll follow the structure of by ID and all ID. By ID is basically we store the values by ID and then we reference through that ID. And then if you have to access something, we just create an array or map of all the IDs and we use it. For example, here I can use the root as ID and then I can store the values inside it, and to this I can have a parent ID. So for root it is null, but let's say if I have folder 1, then I can say that this will become folder 1, name will be folder 1, type is folder, and its parent ID is root. So everything is stored in the flat hierarchy. You can access an element within a constant time, and then if you have to trace back, you can trace through the parent ID. For example, let's say if I have another folder over here called as folder 3, so this becomes folder 3, this becomes folder 3, this becomes folder 3, and its roots become folder 1. Sorry, I have to incorporate this as a string. This also becomes a string, this also becomes a string. Now here, if we have to trace back, we'll find the parent of folder 3, which is folder 1. Then we will find the parent of folder 1, which is root, and then we'll find the parent of root, which is null. So in the reverse order, you can go from child to parent to its grandchild and then find all the elements, or we can have the breadcrumbs. And let's say if you have to get all the elements of the active folder, then simply we can just filter out the elements from this folder by their parent ID. So let's say if you are at root folder, we can just filter out everything whose parent ID is root and we'll get those folder. So this is how you can use the normalized state by ID and normalized state on by ID to efficiently iterate over the folders and the files and can have unlimited nesting, which is scalable. So let's use this structure and then create this file and folder view in React. If you want to study in depth about state normalization and how to efficiently handle states in React, all those articles are also available on this course, so you can read through that. So now we got folder 1, folder 2, folder 3. Let's create one more, folder 4. This will be folder 4 and this will be under folder 2, and then let's have two more which will be files. So this file 1 will be under folder 1, this will be type file, and then here we'll say file 1. Now you can have additional details over here like its metadata and whatnot, but for this question I'm keeping it simple. So here folder 2 has file 2, folder 1 has file 1, and then folder 4 is inside folder 2, folder 3 is inside folder 1. So now let's use this state and then render our structure. So let me clear this. Here I'll create a state to maintain the active item. So active item and set active item, and I'll use state as null. So we'll start with the default active item, and then we'll return a div, and let me type hello world and see if it is printing. So it is printing, hello is printing. Now we have to filter through these folders and we have to find the root element and render it over here. So what I'm doing over here is I'm creating a function const get children, which will use memo. Basically I want to memorize the values, and here I'll pass active item as dependency and the folders, and what it will do is it will get object dot values from the folders, and then I'll filter out e dot parent id equals to active item, and it will return me the. So from the values we are filtering out the one whose parent id is equals to the active item. Now we got the children, let's render it. So here I'll say get children dot map. Remember this returns value, the use memo hook, use callback returns a function. That way I'm directly accessing the, let me rename this children to render or folder to render so that it is easier to understand. Folder to render. Now this value we can use to render it, and here let's return a div with the name of the folder, which is e dot name. When I run this, I'm not seeing a value. Let's check what's happening. So let me console log folder to render and see what we are getting in the output. Use memo is not defined. Okay. So we have defined cannot read properties of undefined, reading map. So it is saying that cannot read properties of undefined. We got folders, we are getting the folder, we are filtering on it. The parent id equals to active item, this is parent id, and we forgot to return from here, that's why we are getting undefined. Now we got the array, this array holds the object and whose name is root. Now if I render this div e dot name, it should be rendered. So here we are seeing root. Let's style it a little bit. Class name equals to display area Let's go over here. So display area, display, let's align items center, and then give a gap of 4 pixels. And then to the folder we'll use a common property box, and I set the width as, let's say, 200 pixels, height as 200 pixels, and then we'll have a separation. So folder type folder will have a background color of, let's say, green, and then the cursor will be pointer so that it is easy to understand that this is a clickable area. And for the file we'll have background color as gray. In the box as well we can say display, let's align items center, justify content center. Let me save this and reload this. We got the root, but the style is not applying. So display area, box, folder, and file. Let's move back here. So we got class name display area. Then to this we have to add class name as box. Now box is applied, and after this box, and then we have to check e dot type. What is the type? Now we got the box here. Let's take it to the top. So adding 10 pixels. Okay. Now we got our folder. Now when we click on this should update the active item, and we should be seeing the next or the nested values or the values inside this folder. So let's do that. Let's add a on click event listener to this. On the click of this, what we'll do is we'll say set active item, and we'll pass e dot id. So if I click on this, the moment I clicked root, we are seeing the folder 1 and folder 2. If I click folder 1, we see that folder 3 and file 1 is there. Because there is nothing in folder 3, so if we click on this, we'll see nothing. So we got our basic functionality working. Now let's have the breadcrumb here so that we are aware where the navigation is happening. For that, what I'll do is I'll wrap the boxes or the folders in a different div and name this as display area, and then we'll have the header area as well, where we'll render the breadcrumbs. So class name equals to header or breadcrumb, whatever you want to name it. Let's reload. So we got folder, and here let's say if I say breadcrumb, then it should be visible. So it is visible that this is the breadcrumb area. Now we have to generate the breadcrumbs. So to generate the breadcrumbs, what we have to do is we'll create a function that will trace back from the current active item to the root, and then it will provide us the breadcrumbs. So let's do that. Here let's have a function const get item path, and then we'll use memo again, and to this we'll pass active item and folders. Actually, there is no need of memo because we are having only one state over here. If there are two states, then it makes sense that we wrap this in the memo, but it doesn't matter. Let me remove this, get item path, and here what we'll do is we'll trace back. So let's have an array of path, and then let current id equals to active item, and then while current id is not null, so if you see the root element whose parent id is null, so that's why we are adding a while loop over here, and that will check while the current id is not null. What we have to do is we have to get the item from the folders with the current id, and if item is not there, then we'll break. This is the base condition. Otherwise, what we'll do is we'll add this item on the front of the path, and here I'll add the name and its id. So id, because once we click on this, that will be set as active item, and that will help us for the navigation, and name because we want the user to see where we are at currently. And then finally you update the current id with the item's parent id. And then finally what we have to do is we have to add the home, because there is nothing after the root, so we need something to show the root as well. For that we'll add a static path home whose id will be null, so clicking on this will show us the root item. So that's why here let's add name as home and then id as null, and after that we'll have our existing path. So this will return us the path, the array of values, and here we'll render it. So let's say const paths, get item path, and then paths dot map so basically we can iterate over it and then join it. Let's add a span, and here we'll have e dot name, and on click of it we'll just set the active item, set active item, which is e dot id. So we got home. For the root, if I click on root, we see that we got home, root, and then folder 1, folder 2. If I click on folder 1, we see that we got home, root, and folder 1, and then finally the folder 3, and there is nothing inside the folder 3. So if there is nothing, then we can add an empty state that will add. But first let's add some more design over here. So we add a separation between two breadcrumb items. So here we mapped it, and after each of it, so what I can do is I can join them. Basically use memo if it is not changed, and here parts get items path. paths, wait, and to this we'll pass the paths, and here this will return as an array. So if I get this, so we got paths mapped, and then we finally have this. Const map, and from here I can return map dot join space and then greater than arrow, and then generated paths. If I render this, let's see, it's returning an object. So we got paths dot map. If I console log this, we got the array. Oh, okay, because this is returning a JSX, so we cannot join it like this. What we can do is we can add a check over here, I, and then here if I not equals to paths dot length -1, which is if I is not the last element, and then you can just add a value. If I click on this, so see, we got the separation over here. If I click on any of this, we can add the class or design to it. Let's say class breadcrumb, and here we can say dot breadcrumb cursor as pointer. So this will highlight if this is a clickable or not. It is also saying that this indicator or separator is a clickable item. That's because I have wrapped that inside a span. So what I can do is I can have an empty tag and then remove this. Can have another span over here and add this. So now this is not clickable. This we can clicking on this, nothing happens on folder 2 because we are already on folder 2. If we click on folder 4, then we are getting nothing. So let's add a check over here, like a folder to render, then do this, otherwise we show something. So here we will use the class name as box only and show empty folder. So let's now test this. If I click on root, I go to folder 1 and then folder 3. It is not generated. If folder to render, then we have this. Otherwise, we should have this one. Let's reload. Check again. It's not rendered. It should be ideally. Under the display area, we got the box, empty folder. Is folder to render getting a value? Let's check that. Console.log and then folder to render. I think it's getting empty array, that's why we are not reaching at the end. Yeah, as I predicted, it's getting an empty array. So let's update our condition. If folder length, so we got this empty folder, and let's add the type also as folder. And then let's design this breadcrumb area. So for the header, we'll say that padding as 10 pixels and background as red. And then between two, so between display area and this, we'll create a wrapper, display flex direction as column, and then we'll give a gap of 10 pixels. And let's save this and come over here and give the class name as wrapper, and we got the gap. So we are on the home. If I click on this, folder 1, folder 3, we got the file and then empty folder. Now on the type of file, we don't want it to be clicked. So that's a edge case that has to be handled. So what we do is we just add a check if e.type equals to folder, then only you want to click on this. For the navigation or updating the active item, all other actions you can handle as you wish, but this is the basic constraint. And for the empty folder, we want to change the colors so that it is highlighted properly that this is empty. So what I'll do is I'll create dot empty and change its color to red, or let's say yellow, so that background color, and color as hash. So this is clearly differentiated that this is an empty folder. And now when you click on this navigations, you can go back, and if I click on any of these, folder 2, folder 4, and the navigation is also working properly, and then we are able to go deep into any of the folders and then pick the items inside it. Now if you want to increase or add any number of folders, you just have to make a new entry in under the folders, and you just have to update the parent ID and everything will work smoothly. For example, let's say if I take file 3 and I add this under folder 2, so now it should be visible without any problem. So if I go under folder 2, we are seeing that we now have two files, file 2 and file 3, and file 1 is under folder 1. So this is how defining the state helps in creating a scalable component. I hope you have learned something new today. Thank you for your time.